Okay, in this video, we're going to be talking about area. So we're starting with this shape, this idea of this backyard again. Remember, before we talked about perimeter being the length of fencing we'd have to buy to go around the outside. So for area, we're talking about what's on the inside. So for example, if we wanted to fill this backyard fenced area with turf, how many of these square, and we're going to say meters because that's what we said before, square meters would we need to buy of turf? So keep in mind, previously we said, okay, this is 3 meters and this is 4 meters. So we call this a square meter, obviously because it's square, but also because, so it's 1 meter on one side, 1 meter on another. And when we go 1 meter times 1 meter equals 1, and you notice we have 2 of the m's, and you've seen this before with exponents. So we're going to say 1 meter to the 2, which also is said squared. So when we're counting area, we're saying, okay, how many of these square meters of grass do we need to buy? For this particular shape, it is very easy to count up that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can say the area here equals 12, and we say of these meters squared, not just meters because it's not a straight line, we need of the 12 of the square meters. So this shape, it's easy to count. But what if we had a bigger shape that didn't have this nice beautiful grid on it? Well, that's when you look at the length of the sides. So we call this, and you can decide which is the width and which is the length. I usually say the longer side is the length and this side is the width. So we can also just say that area equals the length times the width. In this circumstance, I'm going to say our length is this side, 4 meters, and our width is 3 meters. So I'm going to write that in. Area equals 4 meters times 3 meters. I'm running out of space here, so I'm just going to go down to the bottom. Area equals 4 times 3 is 12. And remember, we don't just put meters, but meters squared. So you see that number down here matches what we just essentially counted up. So it's 2 different ways of getting that area. In these next 2 examples, because they're nice small shapes with grids inside, we don't actually need to use our formula for area, but it's nice to know that and be familiar, and we can kind of prove it with these shapes. We'll start with this first one counting up. So the shape is made of unit squares. What is the area of the shape? Keep in mind our unit in the last one was meters. This, they just said sort of a generic unit. So I have 1 square unit, 2, 3, 4, 5, 6, 7, 8. So I'm gonna write 8 square units in there. Would have been a little faster maybe if I said 2 times 4 is 8 up here. I like to say the length is longer. Doesn't make any difference. 2 times 4 is 8. Down here, we do not have a nice rectangle. So this would be a little harder to count up. We could do it by saying, okay, the area of this part, 1 times 3. The area is 3 units squared, and then finding the area of this and adding it together. Because it's small, I think it's easiest just to count. So I'm gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 square units. So here we have our first example where we don't have the grid. If you really wanted, you could sit there and you could draw in the lines. So you had all these little squares, but I think that's kind of a waste of your time because we have this beautiful formula up here that makes it a lot easier for us. We have our length, we have our width, we can just plug in those numbers. So for this one, area equals, I'm going to say 10 meters times 7 meters. Simple math, 10 times 7 is 70. Very careful, please don't write just meters, but meters squared because there's 2 of them. And we're not talking about a length, we're talking about if you had drawn in all these little lines, we would have been able to count up 70 of those square meters. These last 2 examples are using a little bit of the algebraic thinking, but we're looking for a missing length in that one and a missing, you could say width, a missing side in each shape. But as long as you use the formula, you don't actually have to do that algebraic work. They're small enough numbers, you can probably just figure it out. So we'll read the first one. The width of the rectangle is 4 centimeters. The area is 32 square centimeters, or centimeters squared. What is the length of the rectangle? So I'm going to write it out. I know my formula is area equals length times width. Our area is 32 centimeters squared. And we know one of them, we don't know our length, times 4 centimeters. So 32 centimeters squared equals what times 4 centimeters? Can you think or use your multiplication chart? 4 times what equals 32? If you're unable to do that, then you start to use the algebraic and think, okay, divided by 4, but it is 8. 8 centimeters. Be careful about that. Oh, it's got centimeters in there for you. So same concept down here. It says the length of the rectangle is 7 meters. The area is 28 square meters. What is the width? So 28 meters squared equals 7 meters times blank. 7 times what equals 28? If you're not sure, we can do sort of this idea of dividing by 7. But I can tell you that 7 times 4 equals 28. This will be 4 meters. Okay, good luck with this section.